Logical mathematical intelligence, the architecture of reason, causality, and complex problem solving. Welcome back, my friend. I'm really glad you're here. Let's sit together for the next few minutes and unpack one of the most powerful intelligences shaping our world today, logical mathematical intelligence. You know, we usually shrink this intelligence down to something flat like being good at math. And I get why. Numbers, equations, precision, all of that is visible, but underneath that there's a whole cognitive engine running quietly inside the mind, a kind of internal architecture, a blueprint that governs how you make sense of the world. This is the intelligence that lets you look at chaos and instantly spot the hidden pattern. It lets you understand why something is happening, not just what is happening. It pushes you to break things apart, examine the pieces, and rebuild them with clarity and purpose. Logical mathematical intelligence is the intelligence that powers scientists, programmers, engineers, analysts, architects, researchers, economists, and all the people who solve problems others don't even know how to define. And in a world driven by AI, automation, robotics, data, algorithms, cyber systems, this intelligence is no longer just useful. It is the backbone of innovation. What is logical mathematical intelligence? In your project definition, logical intelligence is rooted in Mars and K2 energies, the planets that govern logic, analysis, precision, dissection, and algorithmic thinking. Characteristics described are beautifully clear. Linear reasoning. You crave order. You want structure. You want things to make sense. Concrete reasoning. You break a system into parts to see how it works. Abstract reasoning. You can think in symbols, formulas, code, diagrams, or theoretical models. Causal reasoning. You instinctively look for cause and effect chains. Complex operations. You're built for multi-step thinking, algorithms, problem frameworks, and technical maneuvers. Students or adults with this intelligence don't just do math. They seek order in everything. They test theories for fun. They solve puzzles effortlessly. They analyze abstract ideas with ease. They think in sequences. If this, then that, therefore this. They perform operations fast, because their mind is naturally optimized for it. They see the world like a system waiting to be mapped, decoded, and improved. This is the intelligence that builds the future. How to identify logical mathematical intelligence in children? Children with this intelligence stand out early, if you know what you're looking for. They're the ones who ask why, not to annoy you, but because they genuinely want to understand the mechanism behind things. Break toys, not to destroy, but to investigate how they function. Sort objects naturally, by size, by rules, by shape, by type. Love numbers, shapes, patterns, blocks, mazes, puzzles. Predict outcomes while playing games. If I do this, then that will happen. Notice inconsistencies instantly. They are very sensitive to errors. Create their own rule-based systems for play. Enjoy simple experiments, trial and error, and watching cause effect. These kids are not stubborn, too curious, or too serious. They are systemic thinkers. Their mind wants to understand how the world works, not just accept it. How this intelligence shows up in young adults. By adolescence and early adulthood, this cognitive architecture matures into something powerful. Young adults with logical mathematical intelligence tend to think analytically and rapidly, work comfortably with abstractions, logic, theory, models, formulas, code, prefer structured tasks and predictable frameworks, feel at home in mathematics, physics, coding, economics, data, statistics, build or optimize systems, frameworks, workflows, processes, make rational, evidence-based decisions, enjoy solving complex problems that require deep focus, gravitate toward efficiency, precision, and clarity, thrive in STEM environments. These individuals flourish in fields like engineering, data science, machine learning, software development, architecture, economics and finance, scientific research, technical design, analytics and strategy. They don't just calculate, they structure thought. Their mind works algorithmically, even before they learn algorithms formally. What should education systems do? Practical curriculum enhancements based on your project framework. If schools truly want mathematical intelligence, they need to make systematic changes. Logical learners thrive when structure is paired with freedom to explore. Here's what education must provide. 1. Ordered learning environments. Clear expectations, predictable flow, and consistency. 2. Criteria at the start of every task. Logical thinkers perform best when they know the rules up front. 3. Open-ended problem solving, multiple pathways, not one fixed answer. 4. Convergent thinking activities, syllogisms, logic grids, deduction puzzles, structured reasoning tasks. 5. Experiments that test hypotheses, let them observe cause-effect directly. 6. Puzzles and strategy games, chess, coding puzzles, logic mazes, number games, pure fuel for this mind. 7. Short-term goals for progress, logical learners love measurable milestones. 8. Student-involved rubric design, they enjoy defining quality because structure inspires them. 9. Debate and evidence-based dialogues, let them use reasoning, not authority, but have to make their case. 10. Real-world application of mathematics and logic, finance, statistics, architecture, engineering design, coding, everything that shows math as a living system. These tools build not just math proficiency, they build architects of systems, designers of frameworks, and thinkers who can imagine the world in patterns. A thoughtful closing insight. Logical mathematical intelligence is not just the mind of precision, it is the mind of possibility. A child who looks at the world and instinctively searches for order may one day design the next breakthrough in AI, create systems that help millions, solve planetary problems using data and logic, or build structures, physical or digital, that redefine human life. When you nurture this intelligence, you aren't just teaching math, you're empowering the future problem solvers, innovators, and system architects of our world.